Welcome, my name is Vishal Sharma. In this video, I will guide you through the process of creating an I2C application using a Raspberry Pi 4 and an ambient light sensor. Let us first understand I2C. Inter-Integrated Circuit is a bus interface connection protocol for serial communication. It was developed in 1982. It consists of two wires, SDA and SCL. One is serial data, which transfers the data, and the other wire is serial clock, which carries the clock signal. I2C works in two modes. Master is responsible for starting and stopping the communication as well as generating a clock. Slave responds to the instructions from the master. It can be modified into a multi-system with multiple masters and multiple slaves. A maximum of 128 devices can be connected through I2C. Now let us look at I2C communication in depth. First of all, to start the communication, the master device sends a bit to the slave device. Initially, both SCL and SDA pins are set to high, that is 1. Master device begins the communication by setting SDA as 0 and beginning the clock pulse signal. After this, address is sent by the master. This data includes a 7-bit address of a device. This defines the slave for the communication. Address is sent to every device connected, and each one check if their address matches with the device the master wishes to communicate with. The next bit is a 0 for write and a 1 for read. This is to inform the slave device whether the master wishes to read data from it or write data to it. Next up is an acknowledgement byte, which is sent by the slave to the master, acknowledging that it is ready for communication. It sends a 1 if it is not ready and a 0 if it is ready. After the slave sends the acknowledgement bit, the master sends the 8-bit data to the slave. After the data is received by the slave, it sends another acknowledgement bit to the master acknowledging the successful reception. When the master receives the ACK byte, it stops the communication. This is done by once again setting both the pins, that is SDA and SCL, to high. Before creating our project, we must first configure the Raspberry Pi to execute I2C communication. To enable I2C, open the terminal and type in sudo raspi config. This command will open a window, navigate to interface options and then to I2C. Click to enable I2C. It may be required to restart the device after this step. Alternatively, you can simply navigate to the Raspberry Pi icon, go to Preferences, navigate to Raspberry Pi Configurations. On the window, click on Interfaces tab and click the radio button to enable I2C communication. Restart in this step is recommended. In this project, I have used a BH1750 ambient light sensor to read the values on RPi through I2C and respond according to the sensor value range. Let us understand the interface with the light sensor with Raspberry Pi. First comes the address. The default address of this sensor is 0x23 in a hex value. However, to confirm this, one can open the terminal and type in sudo I2C detect -y1. A matrix with the address of all connected I2C devices will be displayed. One-time low-res mode is one of the different measurement modes in BH1750. This is the most common mode, which at each request starts measurement at 1 lux resolution. After taking the measurement, it automatically sets to power down. BH1750 sensor gives a 2-byte data. In order to convert that into a decimal number, a simple formula has been used in the code that we will see in the next slides. This is the simple circuit for this project. Now let us look at the code. Initially, we import two libraries. One is time, which is basically used for time.sleep function to put a delay in code. Then is smbus, which is used for I2C communication. We create an address variable for the sensor and set it to its default value of 0x23. We create a mode variable and set it to 0x23, which is used for one-time low-res mode. The reference of this can be found in the datasheet of the BH1750 ambient light sensor. A new instance of the data bus object is also created with I2C port set to 1. Each device in the I2C communication line will have a unique address from 0 to 1 to 7. We use hex values in the code to define addresses from 0 to 0x7f, corresponding to the values from 0 to 127. I have created a function called sense. This function is used to read the data sent by the sensor. It uses two variables. One is device address, in this case the address of the sensor, which is 0x23. Then is register address, to which the sensor writes the data. In this case we take the 0x23 register address, onto which the sensor writes data obtained from one-time low-res mode measurement. We then return the input converted into decimal value using the given formula. Furthermore, we use a simple while loop for our main program. We get an input from the sensor by calling the sense function. According to the values, we print the observation on the terminal. Now let's look at a demo of this project. I hope this video helped. Thank you.